Good day, my name is Anwati Chong, and right now I will present on the summary for chapter 21 on aldehyde and ketones nucleophilic addition. For the overview on chapter 21, we have learned on the nomenclature on aldehyde and ketones, physical and spectroscopic properties, the preparation of aldehyde and ketones, and the reactions of aldehyde and ketones. For the nucleophilic additions, it includes the Wittig reaction, addition of amines, addition of water, addition of alcohols, acetal as protecting groups, cyclic semi-acetals, and also some introductions to carbohydrates. For aldehyde and ketones, both contain carbonyl groups in their compound and generally will react with nucleophiles. For the reactivity of the carbonyl compound decreases as the number of R around the carbonyl increases. For the nomenclature, in naming aldehyde using the IUPAC systems, the E ending of the parent alkane is changed to the suffix -al. For example, we have 4-hydroxybutanal, and for ketone, the E ending of the parent alkane is changed to the suffix -on. For example, 4-hydroxy-2-butanon. And both number the chain to give the carbonyl carbon the lowest number. For physical and spectroscopic properties, both aldehyde and ketones exhibits dipole-dipole interactions, and the intermolecular forces increases as the boiling point or the melting point increases. Both aldehyde and ketones are soluble in organic solvents, and for less than 5 carbons, it is water insoluble. Meanwhile, for more than 5 carbons, it is water insoluble. In the IR spectra, the carbonyl groups gives the strong peak at 1700 wavelength. Meanwhile, for the CH of the aldehyde, it gives a peak at 2700 to 2830. For cyclic compound, it increases the wave number as the ring strength increases. For the NMR spectra, the aldehyde absorbs at 9 to 10 ppm, and the proton at the alpha carbon absorbs at 2 to 2.5 ppm. Meanwhile, in 13 carbon NMR, the carbonyl groups give the peak at 190 to 215 ppm. For the reactions flowchart, these are the summary on the reactions for aldehyde and ketones, whereby we have the synthesis of aldehydes from primary alcohol oxidation and oxidative cleavage, and we have ketone synthesized from secondary alcohol oxidations, Friedel-Crafts acylations, and di-organocopper reactions with acid chlorides. For the general reactions, we have the additions of amines, addition of alcohols, the Wittig reactions, addition of hydride, addition of Grignard reagent, additions of cyanohydrides, and Wolff-Nichner reaction. Next is the chosen reactions. The first is Wittig reactions, where it is a reaction of aldehyde or ketones with a triphenyl phosphonium ylide to give alkene. The mechanism of the Wittig reaction includes 3 steps, which is step 1, where the attack of ylide carbon on the carbonyl, and then step 2, where the attack of the oxygen on the phosphorus atom, and step 3, it involves the reverse 2 plus 2 cycloadditions, and the product will be an alkene. In pharmaceutical industry and chemical industry, the Wittig reactions is very important in the synthesis of the beta-carotene and also vitamin A derivatives. Next is the addition of cyanide, where it is a reaction of aldehyde and ketones with sodium cyanide and a strong acid, for example hydrochloric acid, to form the cyanohydrides. It is a two-step mechanism where the first one is the nucleophilic attack with the cyanide ions, and secondly is the protonation using the hydrochloric acid. The cyanohydrines are used in the synthesis of beta-amino alcohols, alpha-hydroxy ketones, and also alpha-hydroxy acids that can be used as the intermediates for fine chemicals and also in pharmaceutical industry. As a summary, both aldehyde and ketones can be prepared through many synthesis methods. For aldehyde synthesis, it can be done through the oxidation of primary alcohol, the reduction of esters and acid chloride, and also the hydroboration and oxidation of alkyne. Meanwhile, for the ketone synthesis, it can be done through oxidation of secondary alcohol, Friedel-Crafts acylation, hydration of alkyne, and also the reaction of acid chloride with organocuprates. Generally, aldehydes and ketones are compounds that can undergo nucleophilic addition reactions, such as the additions of hydride, organometallic reagents, cyanides, amines, water, and also alcohol. These are all the references. Thank you very much.